Hello everyone, welcome to another video where we'll be discussing more questions. These videos are for your IISER and NISER test. Okay, so I hope you're watching all the videos and solving questions. Okay, so this in the previous classes, two classes we discussed electromagnetic wave. Okay, electromagnetic waves. So here we'll be discussing in this video we'll be discussing electromagnetic induction. Okay, these are important topics for your next and IIT exam, electromagnetic induction. Okay. A square loop ACD of area 20 centimeter square, resistance 5 ohm is rotated with a magnetic field B is equal to 2 Tesla through 180 degree. In this second business, find the magnitude of average values of E, I and del Q in both the cases. Okay, let's try. You have 2 minutes to solve this question. Let's try. Okay, so something just okay. Square loop ACDE of area 20 centimeters square. So area is rest, right? 20 centimeters square. Okay. Resistance 5 ohm, R is equal to 5 ohm. Is rotated in a magnetic field B is equal to Tesla through 180 degrees. So theta is negative. In this second. So find the magnitude of average values of EMF you have to find, current you have to find, and charge you have to find. Okay, so just try. Okay, so what will be the flux here? What is the flux? See, let's take area vector S. Okay, there is a S that is perpendicular to the plane of loop. Okay, like it's inwards, right? Inwards, perpendicular to the plane of loop. So initially, your area vector, area vector is also outward, right? So area vector and magnetic field they are like anti-parallel, isn't it? Because your area vector is coming out of the surface and the magnetic field is going in. Okay, and then when it is rotated by 180 degree, when this thing is rotated by 180 degree, now area vector will and magnetic field will align with themselves, right? Isn't it? So they are in the same direction. So the angle between them becomes what? 0 degree. That's why I didn't write theta here, right? Angle is 0 degree. So phi is what? BA cos 0. Okay, so that is 2 into area, that is 20 centimeters, 20 into 10 to minus 4. Okay, so this is a 14 to 10 to minus 4. That is 0.004. Okay, meters, sorry, flux, that means Weber. Okay, and like the, okay, this is now. Now when, okay, this is when the angle is 0 degree. Okay, so when I rotate it by 180 degree, so flux will be, this is flux initial. So yeah, this one is I told it wrong. Let me explain again. See, flux for initially it is 0 degree. So BA cos 0. Final is what? BA cos 180 degree, because it rotated by 180 degree. So that will become 2 into 20 10 to minus 4 minus 1, right? So 40, so this becomes minus 0.004 Weber. So if you see, change in flux is equal to del phi, it's equal to phi f minus phi I. That is that is how much? That is minus 0.008 Weber. Okay, minus 0.008 Weber. Okay, now all the other things are given. So del Q we know, charge is what? Del phi by R, if you remember. Okay, charge is your del phi by R, and del phi is a 0.008 by R. R resistance is a 5. Okay, from here you can calculate. If you see, this will be your 18 10 to minus 3, so that will be your 0, okay, 0.0016, right? 0.0016, that means 1.6 into 10 to minus 3 coulomb. This is your charge. So this is your charge. Now EMF we can calculate. Okay, EMF we know EMF is what? Magnitude of minus del phi by del t, right? Or d phi by dt. So minus, this becomes 8 into 10 to the minus 3, because your d phi we got as 8 into 10 to the minus 3 divided by dt. What is the first time interval? 0.01, right? Minus d phi by dt magnitude, that is okay, 8 into 10 to the minus 3 divided by first time is your 0.01, 8 into 10 to the minus 5. Okay, volt. Is it all right? Yeah. So this is your EMF. And current is what? Your EMF by resistance. So 8 into 10 to the minus 5 divided by resistance. Resistance is what? Resistance is your 20 ohm, right? Something else. 5 ohm, sorry, 5 ohm. So this becomes 1.6 into 10 to the minus 5 ampere, right? So this is your current. Okay, and del Q is I into del T, right? I into dt, I dt. dq is I dt. Otherwise, del phi by R also you can do. Okay, 1.6 into minus 3. Same, you can do both ways. Like dq, you can also do as del phi by R. Okay, which you have both ways you can find. So these are, and the other one you can also find out, right? For time t is equal to 0.002 second, exactly the same way you have to take, and you can solve it. Okay, yeah. Next question. Please read the question. Magnetic flux passing through a metal ring varies with phi b is equal to 3 ATQ minus BT square. Okay. And your A value is given 2.00 second minus 3. B value is given 6.00 second minus 2. Okay. The resistance of the ring is R is equal to 3 ohm. Determine the maximum current induced in the ring during the interval t is equal to 0 second to t is equal to 2 second. Try, please try. Let's try this question. So 5e is given, right? So we can get EMF, right? That is your d5e by dt. That is 6at square minus 6bt. Okay. A is your this and B is your this. Just put the values and you will get it as 12t square minus 36t. So that is yeah 36t, right? So this is what you get. Hmm. Okay. Now where is this? This is the resistance of this maximum current induced. Okay. So see R will be R is given as 3 ohm. I is what E by R, that is this by R, that is 12t square minus 3t divided by 3, 4t square minus t. Okay, ampere whatever. So for current, maximum current. Okay, maximum current means for current to be maximum, what will happen? For current to be maximum, di by dt is equal to 0. Okay, so d by dt of derivative of 40 square minus t, derivative of 40 square minus t is equal to 0. 60 minus 1 is equal to 0. Sorry, 80. 80 minus 1 is equal to 0. So your t is equal to 1 by 8. Is there any mistake? Otherwise, let's do one thing. Let's not put the value of a and b here. Okay. Just let it be like this only. 680 square minus 6bt. Okay, and this is your E. The R is 3 ohm. I will be E by R, that is 680 square minus 6bt by 3, that is 280 square minus 2bt. Okay, 280 square minus 2bt. Is that alright? This is the I. Okay, so maximum current again. For that, we need to do what? di by dt is 0. So di by dt is equal to d by dt of um, 280 square minus 2bt minus 2b is equal to 0. 480 minus 2b is equal to 0. 480 is equal to 2b. B is equal to 2b by 4a. It's equal to b by 2a. Okay, b by 2a. Is there any mistake? Okay, this should be 9. It's 980 square. Sorry, I'm bad again. 3 Ah, this is 9, this is 3. Okay, let me do it again, okay? Not bad. Phi is equal to 3 80q minus bt square. Okay, E is equal to d phi by dt, d by dt of 380q minus bt square. 980 square minus 6bt. Okay, R is equal to 3 ohm. I is equal to E by R. 980 square minus 6bt by R. R is 3 ohm. This is 380 square minus 2bt. The maximum current and di by dt is equal to 0. So d by dt of 380 square minus 2bt is equal to 0. So 680 minus 2b is equal to 0. So t is equal to 2b by 6a. That is b by 3. That's correct now. T is equal to b by 3a. So what we have to do is maximum current. So we have to put this value at current. Current is with this one. So just put the Imax. So put Imax is equal to 3a whole into b by 3a square minus 2b whole into b by 3a, and that will be equal to how much? 3a b square by 9a square minus 2b square by 3a. This is a and this is a 3. B square by 3a minus 2b square, that is minus b square by 3a. Okay, minus b square by 3a. So now I just have to put the value of b, and b value is 6. So 6 square minus by 3 into 2, that is 6. 6 ampere is, okay. So this is Example 27.12. Please try. Figure shows the top view of a rod that can slide without friction. The resistor is 6 ohm and 2.5 Tesla magnetic field is directed perpendicularly downward into the paper. Okay, calculate the force F required to move the rod to the light at a constant speed. At which rate is the energy delivered to the resistor, so that this rate is equal to the rate of work done by the applied force. Please try. Let's try this question. Okay, could you solve it? Easy question. And, see, motional EMF of a rod we know is A is equal to BVL, right? It's called motional EMF. And, So I put the values. B is equal to 2.5 into B is equal to your V is equal to how much? Velocity is 2 meter per second into L. L is equal to length is given 1.2 meter. So this is the EMF. Okay, this will be 6 volt. And current in the circuit is what? Current is equal to simply EMF by R resistance. So EMF is 6. Resistance is 6. So this is a 1 ampere. Current is a 1 ampere. Calculate the force F required to move the rod. So we know force in this kind of motional EMF is ILB, right? So I is 1 into length is 1.2 into magnetic field. Magnetic field is 2.5. So from there you can get it as 3 Newton. Okay, force is 3 Newton. Rate by what? At what rate is energy delivered to the resistor? Rate means rate of energy means what? Rate of energy means actually energy by time. Energy by time. Energy by time is 1 by 10. That is power. So we need to find power. Power here will be I is given R is I square R, right? We know. So I is your 1 ampere 1 square into R. R is how much? R is your 6 ohm. So 1 into 6 that is 6 watt. Okay. So R is your 6 watt. Is it alright? Okay. Now the rate by which work is done so that this rate is equal to the work. Okay. This is so that questions are not. We don't have to do that. So this is your question. Okay. Very easy. Just looks a bit like what is it? It will be hard. No, it's very easy question. Okay. Next, move to the next question. The inductor shown in the figure has inductance. This inductance is given 0.54 Henry. Okay, and carries the current in the direction shown that is decreasing at a uniform rate. Di by dt is given, that is minus 0.03 ampere per meter. Okay, so this is it. Find the self-induced EMF. Okay, self-induced EMF is asked, and at which end of the inductor A or B is at higher potential. Okay, so please try. Again, a very easy question, not hard at all. Okay, so self-induced EMF is L di by dt. 0.54 into derivative is minus. Okay, this is minus derivative. Sorry. Minus into 0.54 minus 0.03. If you multiply them, you will get it as 1.62 into 10 to the minus 2 volt. Okay, so this is your EMF. Simple. And what is now? Which end of the inductor A or B is at higher potential? Okay. So if you see, uh, how will we solve this one? Okay, suppose VBA. So VBA is what? V. Okay, let's start. VB will start current in this direction. Kirchhoff's law. So VB minus L di by dt minus VA is equal to 0. Kirchhoff's law. So VB minus BA is equal to L di by dt. So VB minus BA is our VBA. Okay, VB minus BA, let it be like this. VB minus BA. L di by dt is how much? 0.54 into 1 minus 1.03. So minus 1.62 10 to minus 2. So BB minus VA is minus. That means what? VA is greater than VB because this is coming minus. So if VA is greater than VB, then which of the inductor is at higher potential? A is at higher potential. Okay, is it clear? Second question is the real one, the good one. Okay, yeah, you just have to use Kirchhoff's law. All right, yeah. Next question. Again, in the circuit shown in the diagram, in the figure, R is equal, everything is given. Current is decreasing at a rate this. Find VAB. Okay. Again, apply Kirchhoff's law and try to find this same way I just did the previous question. Please try this one. Okay, VAB. Let's start VA minus IR minus L di by dt minus, this is minus because plus 2 minus this minus E or E is equal to VB. Okay, so VA minus BV is equal to everything take to other side, IR plus L di by dt plus E. Okay, IR is how much? I is 2. 2 into R is 10 plus L. L is how much? L is your 5 into di by dt is minus 1. It's given here. Current decreasing at the rate of minus 1. So decreasing at the rate, it didn't have to write minus 1 here. Okay. Plus decreasing means it's minus 1. Plus E is equal to 20. Okay, because every term should be a potential term. Okay. So 20 minus 5, 15, 15 plus 1, 35. So VAB is how much? 35 volt. Okay. This is the answer. Again, if you know Kirchhoff's law, you can do anything. Okay. This is the truth. This is alright. Next question. Yeah. Calculate the inductance of an air core solenoid containing 300 turns if the length of the solenoid is 25 centimeter and its cross sectional area is 4 centimeters square. Calculate the self-inductance EMF, self-induced EMF in the solenoid if the current through it is decreasing at the rate of this. Okay, please try. Easy questions, don't leave them. First, tell me what is the inductance of a solenoid. Need to remember the formula. Inductance of a solenoid. Inductance of a solenoid L is equal to mu naught n square s by L. Right? Hmm? Is it correct? S is an actual area, n square a by a, whatever you can write. So mu naught is 4.10 minus 7. N is how much? 300, 900 and double, yeah. Area is 4 centimeters, so 4 into 10 minus 4. Okay, divided by length is 25 centimeter, 25 into 10 minus 2. So if you see this are cancelled, right? So this cancelled into minus 5. So 25, okay. Now you can do 16, okay, and this is 16 into 9 is 144 pi divided by 25 into 10 to the minus 5. This is your L. Okay. So you just have to calculate, put the value of pi, you will get it. What is the next one? Calculate the self-induced EMF, that is E is equal to minus L di by dt, we know. Right. Self-induced EMF. So decreasing at a rate of 50, that means what? Di by dt is decreasing. That means di by dt should be negative. Minus 50. So minus L. L is how much? L is your L we got na here. Whatever L you got here into di by dt is minus 50. So put it, you'll get your E. Okay. Is it? Is it okay? Yeah. Yeah. That's it. Very simple question again. I hope you understood. There is no trick in this chapter, electromagnetic induction. It's easy. That's why I just did it so that you first cover the easy chapters, so that you get some confidence that I can solve more questions. After that, you just go to the bit higher level chapter. Okay. First, you gain some confidence. You don't need to go directly to the hard chapter, because you will lose interest. You won't be able to understand properly. You will lose interest and you won't study at all. So first, let's gain some momentum, gain some confidence. Slowly, we'll go to a advanced chapter. Okay. It's gone. Next question. What inductance would be needed to store 1 kilowatt hour of energy in a coil carrying a 200 ampere current? Please try. Easy question. You have 2 minutes. Try to remember the formula for potential energy. Formula for energy. Okay. So current is 200 ampere, and energy is what? Supposed to be 1 kilowatt hour. 1 kilowatt hour is 3.6 10 to the 6 joules. Okay. And what is asked? Inductance. So we know energy. Okay, let it be U. U is equal to half Li square if you know the formula. So half into L into I square, that is 4 into 10 to the 4, is equal to how much? 3.6 into 10 to the power 6 joules. Okay. So from here you can get L, right? This is 2. This goes to this side, becomes 1.8. This is 10 to the power 2, so 180. Okay. You have to do it really fast. 180. Alright. Easy question again. Okay, next question, 27.17. What is the magnetic flux through 1 ton of a solenoid of self-inductance is given when a current of this flows through it? Assume that the solenoid has these turns and is wound from the wire of diameter this. What is the cross-sectional area of the solenoid? Please try. Again, easy question. Don't leave it. Try this question. You have 2 minutes. Okay, done. Okay, what is the magnetic flux through one turn of a solenoid of inductance? This. Okay, let's try it. Have you done it? Okay. See, first of all, self inductance L is equal to what? N phi by I. Okay. How? Because phi is equal to Li, we know. Just a number of terms is there, so we just we just added a n. Okay, n phi is equal to Li. So L is equal to n phi by I. Alright, and here there are how many turns are there? 1000 turns. So L is equal to 1000 into flux phi is equal to flux phi is equal to, okay, phi is not given. Okay, phi we have to find. Okay, I is given as 3 ampere and L is given as 8 into 10 to the minus 5 Henry. So flux is equal to 24 into 10 to the minus 5 by 10 to the power 3, that is 24 into 10 to the minus 8. Okay, so this is the Weber. Okay, and you can write it as 2.4 into 10 to the power minus 7 Weber. Right. So now, what is the cross section? Okay, what is the cross section area of the solenoid? Okay, flux we know is equal to B into A. Okay, and B for solenoid is mu naught Ni into A. Alright. So N is what exactly here? Small n is your L by N. N by L. That means number of turns by length. Okay. So 4 pi into 10 to the minus 7 into N by L. 1000 divided by length. Length of the solenoid is 1. Okay. Wire. 1 millimeter. Okay. So 1 millimeter. So 1 into 10 to the minus 3 into current. Current is how much? Current is 3 into area. Area is your asked. You are asked area, and this is your flux. You can put the flux and you can get the area. Okay. This is the answer. All right. All right. Next question. A 10 Henry inductor carries a current of 20 ampere. How much ice at 0 degree Celsius could be melted by the energy stored in the magnetic field of the inductor? Okay. A 10 Henry inductor carries a current of 20 ampere. How much ice at 0 degree Celsius could be melted? Could be melted by the energy stored in the magnetic field of the inductor. Okay. Energy stored. So energy is how much? E is equal to half Li square. Okay. Energy is completely used in melting the ice. So melting the ice means ice is melted. That means ice is what can we say? When ice is melted means it's converting to water. That means it's change of phase. That means which kind of heat? Latent heat will be used here. So half Li square will be your energy in latent heat. That is ml. Okay. Okay. L is your latent heat of fusion because ice when it melts it's called fusion. Okay, so half Li square, that is L. L is not given. I 20 ampere, that is 400 is equal to mass. Mass is how much? Mass of ice is not given. Na? Oh, how much ice? Mass is asked, sorry. LF is 22.6 into 10 to the power 3. Okay. And L is how much? Inductor is given 10, right? Yeah. So put the values. This is 2000. 2000 is equal to m into 22.6 into 10 to the power 3. So this is cancelled out. So m is equal to 2 by 22.6. Okay. If you do it, you will get it as 0.88 kg. Okay. That will be the answer. Right? Yeah. Next question. This one. Let's try. Straight solenoid has 50 turns per centimeter in primary and total 200 turns in secondary. The area of cross section of the solenoids is 4 centimeters square. Calculate the mutual inductance. Primary is tightly kept inside the secondary. Please try it. You have 2 minutes. Try to cover all the topics of electromagnetic induction. Okay. So if you solve them, I hope you will get some idea and you'll be able to solve everything on your own. Please try. Right? Okay, straight solenoid. Okay, everything is given again. What is the magnetic field for solenoid? V is equal to mu naught. Okay, see magnetic field at any point inside the straight solenoid or primary. Suppose a primary, that means your turns will be n1 turns n1. That means n1 by L, isn't it? Okay, carrying current I1 will be what? B1. Current B1 is equal to mu naught n1 I1. Okay, suppose there is secondary terms, that is n2, and each of area has a. Okay, each of area a. So what can I write? I can write n1 phi 1 is equal to n2 phi 2. Okay, so n1 phi 1 into phi 2. Okay, what is n2 phi 2? See, n2 phi 2 is what? N2 into phi 2 flux. Flux in the second one would be what? Magnetic field into area. Flux in the second one is because of the magnetic field in the first one, right? So n2 into b1, that is mu naught n1 I1, okay, into a. Is it all right? All right. So yeah, yeah, this one. Now what? Now this is n2 phi 2. Okay. Now I will take current to this side. So n2 phi 2 by I1 is equal to n2 uh, into mu naught n1a. Okay, this one I can write mutual inductance. Okay, m. Okay, m is equal to, because m I1 is equal to n2 phi 2. If you are confused, because current in the first one is giving rise to the magnetic field, which is giving rise to the flux in the second one. That is a mutual inductance. Huh? Mutual inductance, two coils. Current in one wire is producing magnetic field, and that magnetic field is creating flux in the second one. Okay, or EMF in the second one. So m is equal to this one. Okay, mu naught n1 n2a. Okay, so you can just now put all the values. 4 pi into 10 to minus 7 into N1. N1 is 50 turns per second per centimeter. N2 is what? 200 turns in the secondary into area is 4 centimeters square, 400 minus. Is that correct? Okay. Yeah. So this will be the answer. All right. Okay. Yeah. So that will be it for this class. All right. And we'll be solving more questions in the upcoming sessions. Okay. We have solved a lot, and in this class, I think 10 questions or something. I hope you understood. I hope, and I just please keep revising. Please keep solving more questions so that you will get some confidence. Okay. Thank you very much for watching. Thank you.